Hello everybody, thank you so much for joining me here on my channel for another video. Today I've got a product review for you that will help a lot of those folks find faint fuzzies with their Dobsonian and push-to telescopes. And this device is called the PiFinder. Now, this is a device that was created by a gentleman by the name of Richard Wolf Jacobson. And he is an engineer and software developer that decided to take the Raspberry Pi single board computer and develop some software around it and install a camera on the side and basically plate solve to find objects in the night sky for you. So you can essentially use this on any telescope that is push-to driven, and you can configure it in many different ways to fit your application. Now this little device though is certainly no slouch for as little as it is. It is small enough to fit in the palm of your hand and only weighs about a pound fully assembled for this particular unit. The advantages of a PiFinder, though, is it's very simple to set up and it's almost no setup required in a way. You just attach it to your telescope based off of that little mini finder shoe there that you'll find on your red dot finder and some of your other optical finders that come on today's telescopes. You'll just replace usually one of those with one of these instead, and basically you power it up, you let it see the night sky, take a GPS fix, and you're off and running. And it's literally almost that easy. It takes probably not even 2 minutes to get this from 0 to hero, and you're out finding targets already. Now, the advantage to this device versus something like encoders that you would find on a Nexus system or some of the higher end models out there is that sometimes the encoders as they age can become problematic, but also if your Dobsonian base is not perfectly square, that can also cause a huge issue with inaccuracy as well. And by replacing those with one of these that allows you to plate solve on every target that you're going to, it basically takes the inaccuracy out of the story, because if let's say your Dobsonian base is not perfectly square, well, that's not a problem, because once you move it over to another part of the sky, it takes a new picture, it plate solves a new calculation, and it guides you towards that object based off of that portion of the sky. It does not take into consideration the whole entire sky like you would with a digital encoder set where you have to align it on several stars each night. This is not like that at all. Now, this little guy does have a GPS inside. It also has several sensors inside, so when you set it up for the night, it takes a GPS fix of your location on Earth, and then as you move this around on the telescope, it has those sensors inside that will tell it how much you're moving up and down and left and right to be able to guide you in those directions towards your target. Now, this has obviously been in your phones and your iPads and everything for years, but to see it come to an astronomy device that is under $500 is really quite something. Now, the PiFinder does feature some physical buttons here on the front, a nice OLED red display here for star parties and nighttime observing. This is the only configuration. It does not color in any way. It is only red for nighttime vision, which is A+. These keys are backlit, as you can see here, and it allows you to basically have all of your scroll buttons left, right, up, down. You do have your number key from 1 to 9, and you also have this extra button over here. Now, this little guy also does have Wi-Fi built in. You can use it for accessing things like Sky Safari if you want to use observing lists. Now, this little device comes in multiple configurations. Now, my configuration here is the screen is on the left side and the camera is on the right side of the finder. So on my telescope, you'll see later on in this video, my eyepiece is over here. So I can, easily see the field of view on the screen as well as the eyepiece. You can get it with the screen on the right side, or you can get it straight through where the screen would just be on the back side and the camera would be out the front. You can get it also in a flat configuration where it would just lay flat on your telescope, kind of like this, with the camera facing forward. It's really up to you which configuration you want to purchase and which telescope you're going to use it on. You can also purchase this with 2 different configurations for power. It does have a lithium-ion battery inside, which is the model I have here. You also can get one that you just plug in a USB cable and power it basically off of just 5 volts that runs through your telescope. Whether or not you have dew heaters and some other stuff, you could just power it through, a little box like that. This device is, like I said, all 3D printed. It is very basic in terms of the fit and form, but it does exactly what it is supposed to do, and that's what matters. You basically just have your interface screen on the front, you've got some power connectivity on the top, your toggle switch for your power, and then also other ones for charging. Now, to purchase this guy, you're looking at different prices for different models, of course. For the standalone model like this, with an internal rechargeable battery, you're looking at $535. And then if you would like the option to just plug it in instead and not have the internal battery, that one is a little bit cheaper at $485. Now, to my knowledge, they are already up to version 3 of the PiFinder. Each version gets new features and new add-ons, and you can, of course, upgrade your software for your own personal device. If you have a slightly older device, you can, of course, upgrade certain components as well. If you're savvy in technology and computer boards, you can purchase individual components and either build your own PiFinder or do upgrades every couple of years to keep up with the latest technology that they've come out with. This does have over 18,000 objects on board, so you will, believe me, never get bored with the amount of objects you can see. And it has almost all of the popular catalogs on here: NGC, IC, Able, Messier, Caldwell objects, planets, etc. It's got everything in here that you really want to look at. Why don't we go out under the night sky, and I'll show you how to get this rocking and rolling on your telescope and how easy it is. And then I'll show you how to get it to find some targets for us, show us some star charts, and just kind of walk you through some of the features out under the night sky. Let's get right to it. We have the 6-inch Dob out here. This is what I like to call skinny mini, if you will. I sourced a old Edmund Scientific 6-inch optical tube from an EQ mount, and it's really tall. I mean, it's probably a 4-foot long optical tube, and just built a relatively tall base for it. But we do have the PiFinder installed up here. I do apologize in advance. I am hand holding this camera here for this demonstration. So you'll notice everything is backlit for us. First thing I want to mention is the buttons here are very intuitive. So as you click them, you can go up and down through the different menus and selections that we have presented to us here. But I wanted to mention these two icons up here in the top. The left one is your GPS signal, and the right one is your camera signal. So the one on the left, once it locks in your date and location and your time, it'll display a solid satellite signal like that. When it's blinking, it's still trying to obtain that. And then the camera, which is on the right side there in the corner, that one will also not be solid when it is trying to plate solve and take its first couple initialization photos. And then when it does lock in the camera position, it will turn completely solid for us. The first thing we're going to have to do tonight is to align the system up with the night sky. Now, sort of just kind of looking in the eyepiece right there, that is Betelgeuse that I have in the eyepiece. So we're going to hit the right tab here on the button for Align. And it is going to present us with this. It is telling us we need to hit the square button to start alignment. And we are going to go down and over. I had it there just for a moment. There's Betelgeuse. We hit the square button again to save. And now we are fully aligned. So you'll see that it displays a star map. And then also Betelgeuse should still be in the eyepiece here somewhere. Yep, it's off there just to the left a little bit, so we're still good. This will get us well within the field of view of the eyepiece. So now you can just hit the back button, and now we are pretty much set up and aligned for the night. Now, at any point, you can always go back into the camera and see what it is also seeing, which you can tell right there. It's got the belt stars of Orion as well as the top 2 stars, and that is how it's doing its plate solving. So that's its current field of view, which is about 10 degrees. And now, if we want to go down, we can just tell it to go to an object. And we're going to try just M42, for example. So by catalog and Messier. Now the beauty of this is once you're in a catalog, you don't have to type any intricate numbers. You can just type 4 and 2 and it'll automatically scroll down. You'll hit the right arrow key And there it's presenting us with those digital numbers for us to be able to move. So now we can just take this and move 13 down. And it's telling us to go to the right just a little bit. Now what I'm going to do is I'm going to let that camera icon come back. You see it resynchronized itself, so we need to go back to the left a little bit. And then go up a little bit. Again, let it just take a picture real fast. Now from here, we should be able to look into the eyepiece. And it should hopefully be somewhere around here. Yep, right there it is. Now, like I said, I am hand holding this, so this is very, very, crude. But you can tell, even with the iPhone on live video, that the Orion Nebula is in fact there. And that is how close to being right on the money it says that we are. Another feature I want to show you is the camera function here. If we go into the camera function, it will show you, of course, the live view that it sees all the time. And we were on the Orion Nebula, but it's drifted off a little bit. You can tell it's not quite perfectly centered anymore. But what you can do is that if you're having issues with accuracy or anything, you can also hit the plus button that will zoom in on the device 2 or 4 times, where you can achieve focus. Now, that little camera that I showed you earlier on the back side here, this little ring on the front, this optical element, does spin. You can spin it either in or out to get a proper focus. And by doing so, you can use this magnifying function to focus the camera up to get the smallest possible stars. Now, mine was a little bit out of focus. The pre-built ones do come shipped with them as best in focus as they can. But of course, during shipping and assembly and pulling the cap on and off 100 times, it'll probably come out of focus after a while, and you'll need to redo this. But the tighter you can get the focus, definitely the more accurate the system, of course, will function. Now, you can go through different objects, and you can also filter different objects. If you wanted to go through and filter what you're seeing here by certain types of objects, certain altitudes, if you're limited at a star party, maybe to 30 degrees or something. Also by magnitude, if you know that, your skies don't permit certain magnitudes, you can, of course, do that. And then also observed. And we're going to find M41 41 and go forward. All right. And then we're going to move the telescope. Let it resynchronize itself real fast. Now it should hopefully be somewhere in the eyepiece. There is in fact M41. That flickering is from the camera on the iPhone. But let's say we wanted to log this object. What we're going to have to do is we just hit the right arrow. And here comes our observing log. So observability, we say, okay, it's pretty observable. We'll do a 4-star, and it's a beautiful target. Let's do this. And we can go in here and adjust the seeing, so the transparency, we're going to say is good. It's a nice clear night. And then the seeing is, fair, just because, most of the time here in Utah, the seeing isn't really that good. And I've got a 24 millimeter eyepiece. 25 millimeter eyepiece, though, is what is preloaded here. We can just select that. And then we just go up and say save. And there it logged our observing for that target. Now you can do this, of course, through the night, and then check all the objects that you've observed and cataloged for the night at a star party or whatnot, and helps you just keep one device here at the eyepiece instead of having to go back and check off certain objects on a pad or on your mobile device or whatever you want. One more thing I'd like to show you about the PiFinder is the use of the square function here. Whenever you're on the main menu or on an object or basically anywhere within the software, you can hold down the square button and it will allow you to have a secondary menu, and some of them are a little bit different. This one just gives you quick tips for help and then also to be able to shut the device down. You don't want to just toggle the power switch off because the little SD card inside could become corrupt just by turning off the power, just like your computer. You want to do a proper shutdown procedure when you do that. But if you're in a target, it'll actually allow you to align on a certain deep sky target instead of just a regular star. So under the regular alignment tab, you'll want to use a star. But let's say you're in the middle of a star party and you found a faint fuzzy. Let's say you found something like the Ring Nebula or something. You can of course tell it to align on a different target. But this is just a very useful functionality of the square button that unlocks just a few hidden features for you. And you just simply push it again to get rid of it and go back to your main screens. After playing around with the PiFinder now for several weeks, I will admit that the Celestron StarSense does work a lot faster in terms of like your phone. It gets you there very quickly, and it really doesn't need a lot of readjustment throughout the night. And I'm finding myself having to basically go near where the target is, let it recalculate, push it a little bit further, let it recalculate again. It takes 3 or 4 recalculations to finally get to the target. But by no means is that really an inconvenience. It's just a matter of you just have to keep letting it do its thing. Now, I will say that me being at Bortle 8 night sky testing this is probably not the most ideal skies for a device like this in terms of, its functionality. I'm sure it will do a lot better and a lot quicker when you can use shorter exposures, and also the much fainter night sky above you will also allow it to have a lot more alignment points than something like just my front yard. However, I will say that it is by far a really awesome device in what it does and the capabilities that surround what it can and cannot do. I really like the observing log functionalities. I really like the ability that you can align on anything, whether it's a deep sky target, a star. You just can't pick planets, and that's okay because in all fairness, planets do move each night, so why would you want to align on planets whenever they are sort of a variable target in terms of coordinates every night? So I really like that sort of functionality that's built in, though, that if you're at a dark sky and you find something and you want to just touch up the alignment on a certain area of the sky, you can certainly do that. I really like the ability, though, of how quick and easy it is to get up and running. You mount it on the telescope, power it on, and literally 2 minutes later, you're aligned and ready to go under the night sky. So if you have a telescope that's, you can just keep it permanently mounted on, then you're pretty much set to go. You just pick it up and carry it outside if you're lucky to live in a dark sky like that. But even if you have to travel somewhere, it'll take its GPS fix for you, and it'll basically do all the legwork of finding all of your targets for you. This is really going to be a device that's revolutionary at star parties when you're trying to look for those 12th, 13th, 14th magnitude galaxies that may not be that big, and they don't have a large surface brightness that when you sweep over them, you're just like, oh yeah, it's there. Star hopping is certainly the old-fashioned way of astronomy, and that's the way a lot of people learn this hobby. And this is not to take away from those people, but this is to assist those people when you are looking for those really faint fuzzies that you might want to find. This device will do everything to help you get to those targets. I have a friend that went after all of the Hickson Galaxy Group targets, and he used an old Celestron C8 and just used coordinates on the telescope, and a device like this, even on something like that, would have been revolutionary and probably a lot quicker to save time than having to use the old-fashioned coordinates. So if you have a chance to pick up one of these devices, I'd highly recommend it. It is a little bit on the expensive side, but look at what you do get for the money. If you opt for the battery-powered one, I have personally had this out now over 12 hours over the course of 4 different nights, and it's never needed a recharge as of yet. But even if it does, it's just a simple USB-C, and it charges usually within about 2 hours all the way back to 100%. As always, thank you so much for joining me. I'll see you next time. Clear skies to you, and have fun out under the night sky.